Thank you, Matt. So yeah, things. A little bit more about me. So what Matt said, and then yeah. So I'm old. I'm programming since forever, since I know how to walk basically. And this is, I don't know if you can see it. This is Commodore Basic 4. So it's really the first experience I had with anything regarding software was on a CBM 600. So that was quite some time ago. But the first contact with Rails I had in 2012 because I picked up this book when bookstores were still a thing in Hamburg, and it really got me hooked into Ruby on Rails because I don't know, this book is just really, it approached me somehow, and going through then I learned about Ruby and Rails, and that just stuck until today. And yeah, so I want to talk about making things more transparent, and I will spin a little story for you here. So not too much, not too big, no big drama, but it's kind of related to my own history. So suppose you or think about joining a new team. You join a new company. You are the new guy. You are that guy. Like, you're full of energy, enthusiastic, you rock the stage and start coding. And because you know Rails already, so it's a Rails team that you're joining, you know Rails already, you know your way around. You know, yes, you know how Rails application works in general. So Ruby on Rails gives you all the conventions and makes you feel at home right away. And the team is really welcoming. Part of this new team, everyone is helping you out, is onboarding you on the new software, and that's fine. You hit the ground running, basically. But then, well, it's a bigger company. There's more than one team, and you do not have enough knowledge about the rest of the company and what every other team is working on, what stack they use, what APIs they have. So it's kind of a mess. It's kind of a mess. And it's really super complex if you're not used to this kind of environment. Also, you have your day job, which like revolves around your team's project first and foremost. So Ruby on Rails is really great when it comes to the stuff that's in the package. So it's batteries included for everything, but it doesn't give you an answer about the things that are outside of your app. You cannot just ask your app like, hey, who are you talking to? And who's talking to you? Can you give me any idea? You can, of course, look at your log output. You can watch your application while it is running and learn something about it. But what you're missing is context. You don't know who is calling and what call is actually doing what with your code. So to the rescue comes, and there's certainly other tools, but to the rescue for this talk comes OpenTelemetry. Which is a really nice tool set I stumbled upon while working with Golang, actually. So I was doing some research into building a data sync-like application, and I wanted to know what's going on inside of the network, and I wanted to know how the latencies behave over time. For example, we have at the company we have business hours where most of the customers are online and checking their things. So you probably know that as well from your own experience. So in the morning you have peak numbers, and in the afternoon you have peak numbers. And so what's interesting is like seeing how the software behaves during this time of day, and also seeing what other parts of the company, other teams' services are calling your software, because they discovered you have this service running and it might be interesting to them. And as we learned yesterday, sometimes people use your software for their purposes and you never thought about that in the first place while creating the software. So you need to look at the running thing. And OpenTelemetry makes that possible. Back then, it was still called Open Tracing, and Open Tracing was, yeah, it's the predecessor to OpenTelemetry, and OpenTelemetry actually is a merger of two projects coming together, Open Sensors and Open Tracing, which is really complex now. And both projects in itself are based on a Google Dapper paper. I think it's from 2010. It's a research paper from Google, and they put a lot of effort into finding out how to build a really performant, huge, but easy to deploy solution to monitor their software, their stack in production. And, well, okay, Google's problems are probably not our problems, but the interesting thing about the Dapper paper is that other teams and open source communities picked it up and used this concept for their own purposes and slimmed it down in a way that it is very accessible for everyone, and you can just, well, I'll show you later. So, OpenTelemetry, what does it do? OpenTelemetry gives you basically the possibility to do traces of requests. So this is like the definition. I took it from the OpenTelemetry page, so that's a bit wordy here. But everything you log usually is without context. So you just like call Rails logger and logger info, logger one, logger whatever, and you put it onto the console for the world to see. But all the context you want to convey, you have to put into your log message, or you have to add request IDs, or do some other hiccups so that in the end someone can make sense of the single log line and maybe see it in context with other log output. And this is something you need to do manually. With a trace, the trace concept basically is a container where you store all this information inside. So logs here are not the first and foremost citizens, but it's spans actually. So a span can have logs, and a span is, think of it as a unit of work. So you would use a span to wrap a unit of work, a method call, for example, or the beginning of a method until the end of a method into a span, and thus have the possibility to do tracing, to know exactly how long it took, when it was called, and in what sequence it was called. And, well, this span is then committed to the trace. And each span can contain other spans, and a span can contain logs. So this is where it comes together. And of course, metrics. OpenTelemetry also provides some metrics, but I would say you probably also have other methods of getting metrics out of your software stack. Probably some of you are using something like statsd to push runtime metrics to Grafana or some other dashboard, or you use Prometheus to get the things out of your application. So there will be multiple solutions. So yeah, let me give you a Supermini example. Supermini. So I created this little sequence here. It's, well, it's a very simple example of an app service which is running inside of your data center, and I bet most of you are not putting your Rails application into the public on the edge. So you have something like DMZ or an edge of your network, so you put a load balancer there and have a reverse proxy forwarding all the requests to your application. And your application usually would probably have an authentication service somewhere inside of your company. So if you have, at least for us, it's like we have multiple applications, but the same user base that every application uses. So we have a central authentication mechanism, databases, of course, and some arbitrary service I called mail, which is triggered here as well. So you can see the flow of the request through the system. It's a bit dry, sorry, but it's self-explanatory, I think. So this is I tried to annotate this so that you can make sense of the traces and spans. So a trace basically covers all your infrastructure. It doesn't cover the browser because the browser is like what the user has, but everything inside of your infrastructure that belongs to your context, to your team's context or your team's domain, can be inside of a trace. And it can even be bigger. So whatever infrastructure the request meets along its way through your infrastructure can be part of your trace, depending on how much effort you take into implementing open tracing in your software stack. And then you can see when when the data is returned from the respective services, I put spans there, and those spans basically contain the units of work that are done. So asking for a user, asking for data from the database. You can instrument not only your methods, you can also instrument the clients you use. So there's lots of instrumentation libraries available for OpenTelemetry, and it's really crazy. I can show you a screenshot. So you are covered. Rails, of course, is a very prominent instrumentation library, but you can, if you're not using Rails, for example, you're using Hanami, you can still use open tracing to, for example, trace your database calls, because MySQL 2 or the PG gem are covered. So you can have some functionality still, and it's probably not that much work to wrap an Hanami action into this instrumentation stuff. So in real life, you will not see these sequence diagrams, but you want to have a nice visual. So there's a web interface. I used Jaeger UI here. So the nice thing about OpenTelemetry is it's an open standard. You're not like locked in by one vendor. OpenTelemetry is just taking care of collecting all the data and making it available. And depending on your flavor of software, on your budget, you can run the software on-premise, like yes, I do with Jaeger UI. My premise is my MacBook, but you can also run tracing tools like Instana or Datadog, not affiliated with any of them, and get this functionality for free if you use traces. I bet the Datadog and also Sentry, the agents, provide this out of the box for some part of the infrastructure. What's also interesting, and that's coming back to my example or to my little story spin from the beginning, you get this for free. You can actually see all the services that are inside of your trace, and depending on the amount of data that has been collected since your OpenTelemetry is running, and the amount of data inside of your data storage, these systems can generate this diagram and a lot bigger diagrams as well. So you can really see what machine is talking or what service is talking to your service, and also you can see if your service is talking to other services. You should know, but if you're new on a team, maybe you don't. And this is really, really helpful to know about dependencies. For example, if you try to have a bigger maintenance window and you need to inform people, so you can do this with a global newsletter, but I don't know, it's probably noise, so you can directly talk to the teams. When it comes to storing all this data, because this needs to be somewhere, that's a mechanism that open tracing or OpenTelemetry called sampling. So there's tracing, which is the actual documentation of what's happening in memory, and there's sampling then. And there are two sampling strategies: head-based sampling, which is the default, and tail-based sampling. So in the beginning, there was only head-based sampling, and DEPA only describes this use case. So what Google tried to do is not build a full-fledged logging application for everything, but because that would just be ridiculous, logging everything and storing it somewhere, like Google. But they wanted to know how their software is performing. And for that, a sample size of maybe 5% or 1% or 0.1% of all the calls of parts of the infrastructure would be sufficient. So they said, okay, when a request comes in and the first app inside of the flow that gets the request and is instrumented, that decides if the trace is going to be sampled in the end or not, because the trace is only valuable if you have all the samples. Every single application can only send spans, and the trace is then created in the end by a software that's called collector. That's somewhere in your infrastructure that's sitting there and waiting for all the spans to come in, because all the parts of all your services know is only the request coming into your individual service and the response going out. It doesn't know about all the subsequent requests coming afterwards, or the previous requests before that still belong to that trace. So your app does not have context. The context is basically determined later inside of the collector. And the collector then, well, whatever it gets in head-based sampling, it commits to the storage and is then persisted for Zipkin, Jaeger UI, Sentry, whatever, to make sense of it. What this does not provide is any kind of error tracing. So because this is really interesting, seeing how a request propagates through the system when you have an error. When systems are burning and you need to react fast, you want to have situational awareness. You want to instantly see where something is happening or did not happen, where call was missing, where something failed. And that's really the interesting thing. But the nature of this head-based sampling is that you cannot know in advance that you need this trace, because it's in advance and you cannot decide up front. Or you sample everything, which is not possible for every use case. So tail-based sampling is the new kid on the block. Basically, for this luxury, you have a trade-off. It costs something. You have the trade-off of added runtime complexity, because you are tracing everything. Every single call is traced by default and sent off to the collector, and then the collector decides if it's going to be sampled inside of your data store or not. And depending on a filter or something, like if an error is there somewhere in the trace, it will be committed to the storage or not. And of course you can mix settings, like I want my 5% or my 0.5% of all the requests, and I want errors. So that's also a nice thing to have. But you have a little bit of overhead with every call, because every single trace is being done in every request. Yeah, a little wrap up. So, OpenTelemetry, yeah, when to use it. So you can use it, of course, when you have multiple services. That was the whole idea. So big data centers, multiple services. It was conceived and at the time when microservices were going to becoming a thing. And it gives context to all these little services everywhere. So that's a no-brainer. If you have multiple services, it makes sense for you to have a look at it. When you have services talking to a lot of other services, so it can also be you have a monolithic service and not many other services, but you talk to other services outside of your organization, so on the internet and with payment providers or with I don't know, open data source thingies. Whatever is your use case, you can decide to have this because you can monitor the latencies and see if you need to change your approach to getting the data that you need at runtime, at production time, because your customers want to have instant responses from your system. And of course, and this is really not intuitive, you can use it for a monolithic application. And that's something that I discovered while, well, others probably as well. I don't claim first discovery here, but when I tried this out with a very simple scaffolded application, maybe if we have 1 or 2 other minutes left, I can show you. So seems to be the case. What OpenTelemetry gives you is that the instrumentation is so nice today. It was not when I first used it, but today it is so nice. You can just drop it into your Rails application, and no matter how big it is, it will be instrumented. A lot of the core Rails parts are automatically instrumented, as well as database calls, Redis calls, and view generation, JBuilder, and so on. And you can have a super transparent picture of what the request actually does inside of your application. And this is nice. So you can also pinpoint bottlenecks inside of your application. Well, when not to use it. So it's really easy to put it into your application, but running it, like operational complexity is always a factor, and budget, of course. So if you want to run it not on premise, but have a provider for this, have a managed provider, or you're paying already for Datadog or Instana or any of these services, maybe check your plan. Maybe it's already in there, and then you can try it out. If not, then it's probably a price tag is attached, but that's, well, expected. If you plan on trying it out, you can also try it out like I did in a local setup, or when I first did it at my company, we have a Kubernetes cluster, so I fired up some pods and had my infrastructure running pretty quickly. And actually, Jaeger, for trying out this kind of thing, is really super easy because it's just one Docker container, one pull basically, and one run command, and you have the infrastructure ready to go so that you can play with it and get your first fix of OpenTelemetry and try it out with your application. Yes, maybe one little, I don't know what I'm doing. Where is it? Okay, so I just wanted to show you the instrumentation that's available for OpenTelemetry. So they're probably very familiar components of Ruby on Rails, but also not so familiar things as well. So if you recognize these libraries, you can get a feeling of what is possible just by adding the gems. Like I think it's 3 gems in the gem file from OpenTelemetry, and a very small initializer to get this running. So that's really cool. Again, I'm not affiliated with OpenTelemetry, but it's really hyped. And having it running, so I used this scaffolded application, and you can see it. And this is now really not interesting. Let me quickly check. No traces found. Yeah, fine. So trying to make some noise here so that live coding. I hate it. Now I'm cheating. Yes. So this is 12 spans. This is just a trace from inside of the scaffolded application. So basically nothing really interesting is happening here, but you can see what is already caught here. So you can find out what part of your application actually did what, and you can see the timings here, which is that's the more interesting part. So you instantly get insights into the runtime of your application. So yeah, that's what I wanted to show quickly. If you have any questions, please reach out to me later. So that's it. Thank you very much for listening.